Welcome to the series of Relational Database Management System. Myself is Fatima Rafiq, Assistant Professor, Abidan Amda Senior College, BCA Department. We have already started with the concurrency control in the last few lectures. We have studied the concurrency control mechanisms like log-based protocol and Thomas timestamp-based protocol. Today we will be starting with a new topic, that is the deadlock. Deadlock is a situation. What is deadlock? Let's understand this. Deadlock is a situation where we have multiple transactions which is executing simultaneously, and one transaction in the schedule is waiting for another transaction is waiting for another transaction, and that waiting is become infinite. So that situation is nothing but a deadlock state. Like for example, consider this particular figure here. T2 transaction is waiting for T1, T1 is waiting for T2, T2 is waiting for Tn minus 1, and Tn is waiting for T0. And this waiting will become the infinite. When it will break, we don't know, and there is no progress in any of the transaction. So this situation is called deadlock. The transaction or the system is in the deadlock state. There are two methods for dealing with the deadlock problem. One is deadlock detection and deadlock recovery. For that particular thing, we will be using wait for graph. Another is deadlock prevention method, that is wait and die, won't and wait. Two methods. What we can do in the for a deadlock, we will have a transaction. Have a transaction. We'll allow every transaction to occupy the data items and just execute it. And after some time, we will be making a graph to identify whether the deadlock is already present or not. If the deadlock is present, we just recover the system from the deadlock. We'll use some methods to recover it. In the second scenario, what we are saying, okay, we don't want deadlock only. So we will prevent the system going into deadlock. That is nothing but a deadlock prevention. So we can use either of two way to avoid the or to handle the deadlock. In first situation, the transaction will execute, and then after some time we'll identify whether it is having a deadlock. If it is having a deadlock, we will remove it. In the second situation, we prevent the system to go in the deadlock itself. So that prevention is would and die and wait and die. We will see the deadlock prevention algorithm first. There are two approaches for a deadlock prevention. Number one, to avoid the cyclic wait order to request a lock or acquire all lock together in the beginning of the transactions. We know that whenever the transaction wants the data item, and if it is holding by some another transaction, that is a situation where the deadlock will come. So in first situation, what we can do, in the first situation, we will allow the transaction to start its execution only if finds it's all data items. If find all the data items, then only the transaction will start. So in that particular situation, what will happen, the transaction has all the data items, so it will start its execution, and once the execution is completed, it will release all the data item. So that is one particular situation which where the deadlock is prevented. Second is perform the rollback instead of waiting for a lock, because the wait may result in the deadlock. The first approach is the approach where the transaction will never start its execution before it acquire all the data item. But in the second situation, what we will do, instead of waiting, we'll perform a rollback operation, because that may result, if the waiting may result in the deadlock. In first approach, it is difficult to predict which and how data item will be required in future. If many data items are required by one transaction and are no longer used, then the utilization of data is very low. In the second approach, we have to scheme using the timestamps. Number one is by using the wait and die method. Number two is by using the would and wait method. The first method is wait and die. It is based on non-preemptive technique. Non-preemptive and preemptive technique. There are two techniques. One technique is preemptive and another is non-preemptive. When a transaction Ti requests a lock on the data item currently held by Tj, Ti is allowed to wait only if has the timestamp smaller than Tj. Otherwise, Ti has to roll back or a die. For example, let's consider three transactions: transaction T1, T2 and T3. Transaction T1, let's take transaction T1 which is having a timestamp as 5. Transaction T2 which is having a timestamp as 10, and timestamp of transaction T3 is 15. If T1 is requesting the lock on the data item which is held by T2. Now currently the T2 transaction is in execution. T1 transaction wants the data item which is held by T2, because in this case the timestamp of T1 is less than timestamp of T2. So what we will do, will tell the transaction T1 to wait. If another transaction comes which is a transaction T3, it requires data item held by transaction T2. Then the T3 transaction will be rolled back. Why? Because the timestamp of transaction T3 is greater than timestamp of transaction T2. So if there are three transactions, so if the transaction is having a lesser timestamp, then the actual currently executing transaction will tell the transaction to wait. But if the new transaction which wants the data item, if it is having a timestamp greater than the transaction which is executing, we will roll back. So that T3, in this particular case, T3 has to be rolled back and T1 will be waiting. So this is called wait and die. The one transaction is in the waiting mode, while the other transaction we will roll back it. We will cancel it. That is, in this case, it's T3 transaction. The another situation or another prevention technique is wound and wait. It is based on preemptive technique. Preemptive means here, like if the one transaction is executing, if the another transaction come, it will wait. It will give the chance to the another transaction. This is called preemptive technique. When a transaction T1 requests a lock on data item which is currently held by transaction T2, then T1 is allowed to wait only if it has a timestamp greater than T2. Otherwise, the T2 transaction has to be rolled back. So the T2 transaction is wound by transaction T1. Consider the example here again. From the previous example, let's consider we have transaction T1, transaction T2 and transaction T3. Transaction T1, let's consider transaction T1 is having timestamp as 5, T2 is having timestamp as 10 and T3 is having timestamp as 15. In this particular case, if T1 is requesting the lock on data item which is held by T2 and T2 will be rolled back. In this particular case, what will happen? The preemption, by using the preemptive technique, what we are doing, we are cancelling the T2 transaction. T2 transaction will be rolled back while the transaction T1 gets the execution. So we can say that T1 wound the T2. In which particular situation? Where the timestamp of T1 is lesser than timestamp of T2. The another case where we have a transaction T3 which is requesting the data item T2, at that time T3 has to wait. Why? Because it is having a timestamp greater than the T2. So in first situation we are wounding the transaction T2. In the another situation we are making we are keeping the T3 transaction for waiting. So this is the prevention technique where the deadlock is prevented.